Okay, so systems in nature tend to progress towards blank entropy and blank energy. Here's how I explain this. It is a little strange and weird, but follow me and you'll learn it. Okay, think of little babies, little kids. Maybe even think of yourselves. I think of little kids though, because little kids seem to always want to be on the move. Now, that's one part of it. So think of young people, kids, teenagers, always kind of want to be moving. You could argue it's a teenager thing, I guess. All right, little kids always want to be moving. Now, then think of really old people, like 100 years old, 95 years old, okay? Not moving so much. Think of the skin of young people. This is where it gets weird. Think of the skin of young people, or babies, or little kids, toddlers, or even your age. Think of your skin now. Think of your skin when you're 95 or 100. So I'm trying to get you to think of an analogy here to understand what goes in these blanks here. So as we progress, as humans progress through time, as you get older, so you start out very young, obviously, baby, toddler, blah, 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 and then hopefully we all live to be 95, 100, and still can function and all that good stuff. Now, let's talk about entropy first. The skin analogy is the entropy part. How would you describe the skin of a young person? Smooth, fresh, tight, okay? Yep. Okay, again, it's weird, especially talking to teenage, high school kids about this. I get it, your mind goes places. But yeah, so those words describe the skin. Now, old people. Right, so I did this in period 2. All right, when you do this when you're 95, what's going to be happening? You got everything flopping around there, right? So now when you're 95, okay, now I'm making fun, I'll be old someday, whatever, we all will get there. So it happens, that's natural, that's normal, so don't take me the wrong way. But the skin is hanging off your body, it's not tight, it's wrinkly, maybe hair's falling out as well, okay? So, how does that help you learn the first part of this? As systems in nature, as things progress in time, what happens to the disorder of the human body, the skin, for example?
Back down.
The disorder, it goes up.
Yeah.
So when you're younger, your skin is together.
Yeah.
High entropy
Order.
when you're older.
Low entropy when you're young. Things are all where they're supposed to be. When you get old, things start falling apart. Lot of disorder, right?
Got that right. Wow.
So as things in nature, so we are part of nature, progress,
I just guessed.
high entropy. Think of a car, brand new car. 30 years after you buy a new car, it's probably basically, barely standing. It's falling apart. Everything, think of houses, everything falls apart eventually. That's a lot of disorder. When things fall apart, chaos, disorder. You with me on that?
Yes.
Okay. Now what about energy? Little kids, okay, like my daughter, she's crawling now. Well, she's been crawling for a while. She's crawling all over the place. She pulls herself up on things, kind of does this. You guys know what that's called? It's called cruising. That's what they call it. So she like cruises on the ottoman, and then, sometimes she misses it. Whoop, now she goes, but it's all right. She's usually okay. Well, she is okay.
Usually?
What I mean is she usually doesn't cry. Sometimes she scares herself. Anyways, we watch her, obviously. Point is, she's always moving, so she has a lot of energy, right. Well, when you're 95, going from the couch to the bathroom is like, an event. So there's not a lot of energy there. So what's the answer here? What are we putting here? Right, low. So as we progress, right, so stay with me. As we progress, as we get older, we fall apart. That's more disorder in our body, high entropy. And we also move less, low energy. You can apply that to most systems in nature. You know what the universe is doing right now? It's not really falling apart, it's constantly doing this.
Stars are
Getting older.
It is getting older. Expanding, right. So expanding, think of gas particles expanding, lots of entropy, lots of movement, okay? All right. So the reason I brought that up now is we've talked about entropy, we've talked about energy a little bit. Yes, sir?
I
I'm on my Teach account finally, and I wanted to know where do I verify, or where do I?
Oh, yeah, I don't think I know. I don't
You
think
recognize it? Did you see it?
Maybe.
Sorry to ruin your video.
Oh, that's right.
Guest star.
Cameo.
And these look like.
Maybe. I don't know. Just click on that one. Try that one out.
That's what I was thinking, but.
Yeah, I have no idea. So, all right. Yeah. What do you have next period? Oh, you have ag, right?
Yeah, I did.
Man,
I
I'm
can
always
talk
happy.
to
All right. I'm leaving at like 2:45. But.
I was pissed. Yeah.
Um,
No, man.
All right. So, anyways, that's that. And that sentence that we just wrote is literally word for word on the Regents every once in a while. It's the same question over and over. It's not on every year, but you will see that, if not on that test, on your first quarter test. So you will see that question. All right. Okay, I think that's it. I want to make sure I went over that. Okay, next thing, we're learning something new. Here we go. Particle diagrams. Who's excited for something new?
Not me.
Of course not. All right.